Hello everyone, myself Netra, studying in Sri Venkateswara College of Engineering, Bangalore, in the Department of Computer Science and Engineering. Today I am going to discuss a topic called polymorphism in Java. This is in Oops in Java. First, introduction to polymorphism in Java. Polymorphism is a fundamental concept in object-oriented programming. It allows objects of different classes to be treated as objects of a common superclass. Polymorphism help in achieving code reusability and flexibility. Next, types of polymorphism. There are two types of polymorphism in Java: compile time and runtime. In compile time can further be divided as operating overloading, method overloading. Runtime can be further classified into method overriding. Next, method overloading. Method overloading is a form of compile time polymorphism. It allows multiple methods with the same name but different parameters in a class. The compiler decides which method to call based on the arguments passed during the method call. Next, method overloading example. In example, in the example shown in the figure, a class has two methods with the same name, calculate area, but different parameters. One method calculates the area of rectangle, while the other calculates the area of circle. The appropriate method is automatically selected based on the arguments passed during the method calls. Next, method overriding. Method overriding is a form of runtime polymorphism. It allows a subclass to provide a different implementations of method that is already defined in its superclass. The method says the subclass must have the same name, return type, and parameters as the method in the superclass. Next, method overriding example. In the example shown in the figure, a superclass shape has a method draw that prints drawing a shape. The subclass rectangle overrides the draw method to print drawing a rectangle. When an object of rectangle class calls the draw method, the overridden method is executed. Next, dynamic method dispatch. Dynamic method dispatch is a mechanism by which the correct version of an overridden method is called at runtime. It is achieved through the use of super keyword and the concept of inheritance. The JVM determines which version of method to call based on the actual object type at runtime. Dynamic method dispatch is one of the mechanisms by which a call to an overridden method is resolved at runtime. When an overridden method is called through the object of superclass, then Java determines which version of that method to execute based upon the type of the object being referred to at the type the call occurs. Hence, the determination is made at the runtime. Go through the example below. Abstract classes. Abstract classes can't be instanted but can be used as a base for other classes. They can have the abstract and non-abstract methods. Abstract methods are declared without an implementation and must be overridden by the subclass. Abstract class. Abstract class is concept and implementation gets completed when it is being realized by a subclass. Abstract class, it provides elements of both inheritance and interface. It is a class that can't be instatisticated itself, it must be inherited. Some or all members of the class might be unimplemented, and it is up to the inheriting class to provide that implementations. Members that are implemented might still be overridden, and the inheriting class can still implement additional interfaces or other functionality. Abstract class example. In the example as shown in the figure, an abstract class animal has an abstract method make sound. The subclass dog extends the extends the animal and class and provides an implementation of the make sound method. The subclass cat also extends the animal class and provides its own implementation of the make sound method. An abstract method is a method declaration without a method body. An abstract method simplifies behavior but no implementation. Next, interfaces. Interfaces defines a contract for classes to adhere to. They can contain only method signatures and constant. Classes can implement multiple interfaces, enabling multiple inheritance of behavior. Next example of interface. In the example as shown in the figure, an interface drawable has a method draw. The class circle implements the drawable interface and provides an implement of the draw method. The class rectangle also provides the drawable interface and provides its own implementation of the draw method. Next, advantages of polymorphism in Java. Polymorphism allows for code reusability and flexibility. It simplifies the code by making it more readable and maintainable. It enables loose coupling between objects, promoting better design and modularity. The ability of reference variable to change behavior according to what object instant it is holding. Polymorphism enable you to write programs that process objects that share the some superclass as if they are all objects of that superclass. The capability of an action or method to do different things based on the object that it is acting upon. Next, polymorphism versus inheritance. Inheritance is a mechanism for code reuse and creating an hierarchy of class, whereas polymorphism is a mechanism for treating objects of different classes as objects of common superclass. Polymorphism can be achieved without inheritance, but inheritance enables polymorphism. Next, polymorphisms in collections. Polymorphism is widely used in Java collection. The collection framework allows storing objects of different class that share a common superclass or implement a common interface. This allows for greater flexibility and ease of use when working with collections. Next, common pitfall of polymorphism. Care must be taken when overriding methods to ensure that the method signature remains the same. Incorrect method signatures can lead to unexpected behavior and runtime error. Polymorphism can sometimes result in performance overhead due to method lookup at runtime. Next, summary. Polymorphism is a fundamental concept in object-oriented programming. It allows programming of different classes to be treated as object of superclass. Polymorphism can be achieved through method overloading and method overriding. Method overriding is a form of compile-time polymorphism achieved through multiple methods with the same name but different parameters. Method overriding is a form of runtime polymorphism achieved through providing a different implementation of a method in a subclass. Polymorphism promotes code reusability, flexibility, and better design.